In this discussion video, we will do some practice problems finding absolute extreme values. So these are absolute max and min values. All right, so I want to start with this example in which I find the absolute extreme values of f of x equals x to the third minus 6x squared on the interval from 1 to 5. And I also want to find the x values where they occur. Okay, so I want to first give you 4 minutes to try this. Pause it in 4, 3, 2, 1. Pause it and try it for 4 minutes. Alrighty, so hopefully you did that. Let's talk about it together. So I first just want to notice that our function here is continuous. It's a polynomial, and that's going to be continuous everywhere, in fact. And our interval that's given is a closed interval. So this is a closed interval. So the extreme value theorem guarantees that because our function is continuous and this is a closed interval, EVT, extreme value theorem, guarantees that our function has an absolute max and min on this closed interval. So remember, our process is to first find the critical numbers. All right, so we will need to take the derivative here. So our derivative, this is going to be some power rule. For the first term, it's 3x squared, and then I'll get minus, and I'll have 12x for the next term. All right, so I need to know when is my derivative equal to 0, and when is it undefined. So to set it equal to 0, let's factor a 3x out of our two terms. So we'll get 3x times x minus 4 equal to 0. And now I can see that x is either 0 from the first term or 4 from this thing in the parentheses. Alrighty, and our derivative, f prime of x, it is never undefined. Because there's no values of x that would say make a denominator 0. This is never going to be undefined. Okay. I should do a quick check that the values that I got, the 0 and the 4, these two numbers, that they're actually in the domain of the original function. Because if they weren't, then they wouldn't be critical numbers. But just doing a quick check, 0 and 4, they are both in the domain of this original function. So they are going to be critical numbers. So our critical numbers here, they are x equals 0 and x equals 4. And x equals 4. Okay, so we are on to our next step. All right, so the next step is we plug in the critical numbers in our interval, which is the closed interval from 1 to 5, and the endpoints of the interval, and the endpoints into f to see what's the biggest output, that'll be the absolute max, and what's the smallest output, that'll be the absolute min. Okay, so as far as our critical numbers go, we had two critical numbers, 0 and 4. Only one of them is in this interval. So we only have to worry about x equals 4. Only x equals 4. All right, so now let's plug in some numbers. All right, so let's plug in 1 into our function. That's one of our endpoints. Okay, so our original function is up here, x to the third minus 6x squared. So plugging in 1, we get 1 cubed minus 6 times 1 squared. So it's 1 minus 6, which is negative 5. All right, so now let's plug in 4. That'll give us 4 cubed minus 6 times 4 squared. And if we evaluate that, we get 64 minus 96, which is negative 32. And if I plug in the other endpoint, 5, we will get 5 cubed minus 6 times 5 squared. And this is a 125 minus 6 times 25, that's 150. And this gives us negative 25. All right, so looking at these values, the largest is the negative 5. That's going to be our absolute max. Our absolute max value. is negative 5. It also wanted to know where that occurs. And it occurs at x equals 1. And the smallest output was the negative 32. This is our absolute min. Absolute min value is equal to negative 32. And where does it occur? And it occurs, occurs at x equals 4. At x equals 4. All right, let's move on to the next example. All right, so this is problem number 4 from worksheet 9, and I have this function g of t, which is cosine of 2t plus 2 sine of t. I want to find the absolute max and min values of g on the interval from pi over 3 to pi. This time pause it for 6 minutes to try it. 4, 3, 2, 1, 6-minute pause to try this one. Alrighty, so hopefully you did that. Hopefully you paused it and tried it for about 6 minutes. Let's talk about it together. Okay, so this function is going to be continuous everywhere, in fact, because cosine and sine are continuous everywhere. And adding two continuous functions is continuous. All right, and our interval is closed. So this will be guaranteed to have an absolute max and absolute min by the extreme value theorem. So we are ready for our process to find those. And that starts with finding the critical numbers. So we got to find the critical numbers on our interval from pi over 3 to pi. So let's take our derivative. So g prime of t. This is going to involve some chain rule. Derivative of cosine is negative sine. Negative sine of 2t times the derivative of 2t, which is 2. And then plus, I'll get 2 multiplying sine. So when I do the derivative, the 2 will multiply the derivative of sine, which is cosine. So 2 cosine of t. All right, and I am going to need to figure out, well, when is this equal to 0 and when is this undefined? And I need to be able to factor this to figure out when it's going to be equal to 0. And that's where this hint, these formulas will come in. One formula is for what sine of 2 times some angle is. If I use that on sine of 2t, we'll get negative, and then we'll get 2 sine of t times cosine of t. And then we still have times that other 2, and then plus 2 cosine of t. All right, so this is my derivative. All right, g prime of t equals, and now this is nice because both of these terms have this cosine, which we can factor out. In fact, I can also take out a negative 2 maybe. So I'll take out negative 2 cosine of t, and in doing that, I'll be left with, let's see, 2 sine t from the first term, and then minus 1 from the next term. And now I can see what happens when I set this equal to 0. My derivative will be equal to 0 when either the first term from the cosine t, either when that equals 0, or when the thing in brackets equals 0. And that'll happen when sine of t equals 1/2. And for both of these, I got to remember my unit circle stuff, and I got to keep in mind I'm limited to the interval from pi over 3 to pi. And on that interval, cosine of t will be equal to 0 only when t is pi over 2. So that's coming from unit circle. And sine of t will be equal to 1/2 only when t is 5 pi over 6. I don't consider pi over 6 because pi over 6 is not in the interval from pi over 3 to pi. All right, so that's when my derivative is 0. My derivative is never undefined. It's never undefined. I never encounter a scenario where I have a denominator and you need to worry about the denominator being 0. Okay, so we have these values. These values, they are in the domain of the original function because the domain of the original function g is all real numbers. Okay, so these are critical numbers. All right, so let's state that. Our critical numbers here. Well, let's just write the critical numbers in our interval. The critical numbers in the interval we care about from pi over 3 to pi are these two. We have t equals pi over 2 and 5 pi over 6. And now we're ready to plug in the critical numbers in the interval from pi over 3 to pi, and the endpoints, and our endpoints into g, into our function g. So remember, g of t was cosine of 2t plus 2 sine of t. All right, so let's plug in the endpoint pi over 3 into this. And doing that, we'll get cosine of 2 times t, which is 2 pi over 3, and then plus 2 sine of pi over 3. And evaluating this, cosine of 2 pi over 3, that is negative 1/2. And then I get plus 2 times sine of pi over 3, that is root 3 over 2. So that's coming from unit circle stuff. And if I simplify, this is just negative 1/2 plus, and then the 2's cancel, and I get plus root 3. Okay, and if I use a calculator to approximate this, this is about 1.2. All right, now let's plug in our critical numbers. Like we have pi over 2. We will also have 5 pi over 6, and then we'll have to plug in the other endpoint, which is pi. All right, if I plug in pi over 2, we'll get cosine of 2 times that, which is cosine of pi, and then plus 2 times sine of pi over 2. Cosine of pi is negative 1, and then plus 2 times sine of pi over 2 is 1, and this just becomes 1. If I do 5 pi over 6, we'll get cosine of 5 pi over 3 when I multiply that by 2, and then plus 2 times sine of 5 pi over 6. And this equals, well, the cosine term will become 1/2, and then I'll get plus 2 times. The sine term will be, let's see, this will also be 1/2. So I get 1/2 plus 1, that's 3/2. And then finally, if I plug pi in, we'll get cosine of 2 pi plus 2 sine of pi. And cosine of 2 pi is 1. And then we get 2 times sine of pi, which is 0. 1 plus 0 is 1. All right, so looking at these numbers, I can now state my absolute max and min values. So the absolute max value was the biggest of these outputs, which is 3/2. And the absolute min value was the smallest of these outputs. The absolute min value is 1. Smallest of these outputs. And that is our answer. This question didn't ask us to state the x values at which they occur, so we could stop with this.